be on track here. Some of you know me already. Many of you don't. My background is widely varied. I consider myself probably an interdisciplinary infidel. I don't really fit in anywhere particular. What I do enjoy is patterns and collecting together from many different disciplines how we do things, how we gather observations about our environment, and how we turn them into something useful, and how we make decisions using this information. So I spend a lot of my time abstracting and generalizing and modeling how we do things. And of course, environmental problems are a key problem that I look at. What I'd like you to do is join me in generalizing. I'm going to show you a lot of examples using watershed monitoring and hydrology, just because it's a really easy environment to do some of these things, because you've got interesting things happening relatively often. But I want you to go along this path with me generalizing, thinking about it not just being hydrology or hill slopes, but also thinking about things like urban and civil hazards and security, thinking about it as building monitoring, health monitoring, and so on. So what I'm going to do is, because this is supposed to be a workshop where we're looking at where we are and where we're going, I want to try to look at things pointing out an approach to doing environmental monitoring, specifically developing technologies for environmental monitoring. And so hopefully using the examples of the projects that we've done over the past 7 years, that we can get sort of this approach to what we could do if we go about things the right way. So just stepping back, we always want to think about why we're doing what we're doing. You know, why are we doing environmental monitoring? What's the purpose of understanding our environment? First of all, what? We're looking at patterns and inventories to see where things are and where we get clumps of them. But we also want to look at process. How does this environment work so that we can identify change in the pattern? And of course, part of this is to identify events, things that are happening that are important, whether it's we've entered a new state or some very specific moment in time has happened to change things. And so how do we do this as people? How do we understand these things about our environment? Well, first we describe. We take an inventory. Where are things? We then do classification. What are things of the same type? We continue on by identifying specific things within these categories. And of course, monitoring, we do this over time so that we can find changes. And of course, when things do change, events happen, we want to respond. What would be far better than following this chain, though, is that once we hit that monitoring stage, we'd like to be able to predict and respond before things have even happened. That's really a key thing that we're after. Whether it's moments before the landslide happens, or perhaps decades before climate change obliterates everything. Take your pick. Lots of scales in there. So in this process, we use sensor networks and sensor webs. My title is the sensor web, and of course, sensor web's nebulous. What the heck is that? Don't ask me. There's so many definitions of sensor networks, sensor webs. It's nearly religious in some cases. No, that's not the right definition. I think it depends who you are and what you're doing. I like to play nice. I play with everybody. And I like to take a very general view and then use specific definitions for specific problems, because that's when they're useful. We can then use them to guide solutions. So for the sake of this talk, we can think about sensor networks. You need sensors, something measuring something out there, and some kind of station that organizes that behavior. You need communication. The data's got to get from here over to here somehow. You're going to process the data in some way, and you're going to store it somehow. That's a sensor network. A sensor web, and again, this is probably where there's more religious battle as to what's what. This is the way I piece it together, in a very broad way. And we keep the specific definitions, again, for specific problems we're trying to solve. A sensor web, several sensor networks. Whether you think about it as moats, or whether you think about it as a whole network of different stations that you see installed along the highway. They act as one virtual network. Right now, I don't care how they do. They just act like a virtual network. Maybe they're all talking to each other and collaborating and making decisions. Maybe it just is, it looks that way to me. That's really the important part. They may be collaborative, they may not. It may just be you're combining stuff together from multiple places. They might have no idea about each other. The real key here is this word interoperability. That's the key to doing sensor webs. You have to have things play nice. We're joking about compatibility things here because, you know, moving a map over and having a cable. But think about 10 years ago trying to do this. It would have been a nightmare. You want to change the computer? I don't think so. But meanwhile, we've got a USB thing that just plugs in, and we work on a different operating system, and it works on, you know, your Intel platform. And we went to the web, and we've got, you know, HTTP to pull the things down. It's all working on TCP/IP. You know, I can grab a cable, plug it in, and know it's going to work. That's interoperability. We have some defined ways of doing stuff. I don't care how you do it, but when you talk to the rest of the world, this is what you need to be able to provide. We agree to a contract on standard ways of doing stuff. So you can implement it however you want, but then you talk nicely when you need to talk to someone. That's how you can plug your DVD player into your TV. It doesn't matter who made it, it's going to probably work. Yes, you have to worry about HDMI versus this, because again, you're going to have one standard. Hey, may as well have 12 standards, right? But again, they all have purposes. But the idea is you've got some way of connecting these things together. And we've become quite accustomed to that in certain parts of our world. I mentioned a bunch there. USB, TCP/IP, these kinds of things. In the sensor world, we've got all kinds of standards, like Zigbee, for example. You know, we've got lots of these different things. For the geo-positioning, maybe it's a little less familiar. So for example, some organizations that work on interoperability, Open Geospatial Consortium. It's been a key one. It's stakeholder driven, lots of organizations involved, for doing geospatial and location-based services. These are the kinds of things that let you do things like Google Maps. They've got their own standards, yes, but the way we take data from one infrastructure to another and be able to use it in an application is because we have things like simple feature descriptions and this kind of thing. On the sensor web, OGC has a sensor web enablement group that is working on their purpose is to develop standards for real-time integration of sensors. And the key thing here is interfaces and codings. They don't tell you how to do it. They just tell you if you want to talk nicely to other systems, here's how you need to make things look. Here are the types of functions you need to be able to provide. Here's the language we're going to talk. Do what you want inside, but if we follow these, we can start stitching pieces together. And they've got tons of different standards. Some key things are sensor observation services, so that we can get data back and forth. And we describe it using different kinds of formats. Sensor planning services, so we can tell that automated vehicle, for example, if we're looking at something airborne, so that it can direct to carry out a mission. We look at sensor alerting services. Maybe we don't want all the data, we just want when certain things happen. We have all these different standards. And of course, they build on other standards, like web notification standards and other web services, which of course all rely on HTTP and all these kinds of things. So we've got this stack. Particular for sensors is sensor observation system. It's a consistent way of discovering services that are out there, what kind of sensors there are and what they deliver. So the metadata is carried out by sensor ML, sensor modeling language, and then a way of getting the actual observations from that service. You ask a question a certain way, you're going to get an answer a certain way. That's really the key thing. So we can think about these interoperable standards to help us piece together a view of the world where we have the sensor network. And it may be made up of all kinds of different kinds of sensors, chemical sensors, geophysical sensors. They might be mobile, they might be static, they might be in situ on the ground, they might be remote. Doesn't matter, they're sensors. And they're feeding data into models and simulations and calculations. They're also feeding data into decision support tools, which might be just throwing up a map so I can go see where restaurants are. It might be something much more complex in doing decision making. So far, the arrows tend to go this way and that way. But ultimately, we'd like things to be flowing all the way around, mediated by these kinds of sensor web enablement standards. Now, that's an interesting way of looking at it. But like I said, we've got all these different people doing different things. And we can take this generalized model, and the OGC tribe looks at it this way. Well, there's sensors, sure. But look over here, once you're on the web, we've got these servers and these authentication things, and they all chain together and mash up, and look at the detail, this is great. Oh yeah, and there's some sensors. Assuming the data arrives from somewhere, look at all the things we can do.